as your choices. And you can
Right. Thank you very much for the introduction, and thank you for having me in this conference. So today I'm going to talk about consumer privacy and platforms data collection. These companies, some of which sponsor this conference, operate large online platforms which collect data from users. And this data collection may improve their services and benefit users. But this data collection also raises growing concerns for consumers and policymakers. I'm going to show you a very simple dynamic game theoretic model in which we can talk about privacy, data collection, regulation, and so on. Given time constraint, I'm going to mainly focus on the monopoly platform. But later, I'm going to talk a bit about competition between platforms. So let me show you the benchmark model. So this is a dynamic model, and time is discrete and infinite. It's so simple that there is just one consumer and one platform. And this consumer has a type X, which is drawn from before time 1 according to some normal distribution. So think of this as some persistent characteristics of an individual, like a race or a political preference, maybe, and so on. This type, once drawn, never changes over time. Purely to simplify exposition in this talk, I'm going to assume that consumer does not observe a realized X. You may feel weird, but this is without loss of generality in a way I explain in the paper. Now, the consumer at the beginning of each period, they choose a activity level, AT. This is any non-negative real number. Intuitively, activity level represents how actively the consumer uses the platform service. Then, consumer's activity list determines the quality of information the platform gets. In each period, the platform observes this activity level itself and some signal, this X plus epsilon T. So this is some information about consumer's type, where epsilon T has a variance 1 over AT plus gamma T. So first, if the consumer sets 0 activity level, then the variance is infinity. So this signal becomes a pure noise from which the platform learns nothing. As the consumer chooses a higher activity level in that period, this increases the precision of the signal, so the platform can learn more about the consumer's type. But there is another additive term, gamma T, which is the privacy level of the platform in period T. So this is going to be a choice of a platform. I call this a privacy level because higher gamma T reduces the informativeness of the signal, so platform learns less from the signal about consumer given any activity level. And the X and all noise terms are mutually independent. So the key here is that in each period, the platform gets some signal. The quality of the signal is increasing in the activity level chosen by the consumer and decreasing in the privacy level chosen by the platform. So since the type is persistent, platform may be able to learn about consumer type over time. Now, how does this information enter the payoff of each player? So this is a platform's each period profit at the end of period T. Simply, the payoff is this exogenous prior variance, known exogenous variance, sigma squared 0 for normalization, minus this endogenous object, sigma squared T. This is the conditional variance of the consumer's type X at the end of period T, given all the information generated up to period T and base rule. So intuitively, if the consumer has very actively used the platform gets a lot of good signals, accurate signal, so sigma squared T goes down and platform profit goes up. So this is somewhat black box way of capturing the idea that the platform can generate revenue by having more information. For example, background story could be through targeted ads. And this profit is increasing in the past activity levels, and fixing the activity levels, it's going to be decreasing in the past privacy levels. So this is a within period of profit, and platform is going to maximize the sum of discounted payoffs. So platform wants to have more information. What about the consumer's payoff? Here is again the consumer within period of profit at the end of period T. Consumer cares about two things. Consumer gets a gross utility from the service, UAT, which depends deterministically on the activity level alone. and this is concave and maximized at some interior activity level A max. But the consumer cares about privacy in the following sense. In each period, the consumer incurs a privacy cost, where V is an exogenous, non-negative, and deterministic parameter. This is the consumer's value of privacy. So if the platform knows a lot about the consumer, sigma square T goes down, and privacy cost goes up, and the consumer gets lower utility. So I agree this is a bit extreme, but I think this is a tractable starting point to capture the idea that for the various monetary or non-monetary reasons, consumers may want the platform to have less information. So this is within period of utility. And for the moment, I assume consumer is myopic. Consumer myopically chooses a T to maximize this within period of payoff in each period. Later, I'm going to talk about forward-looking consumer. Now, we consider the following game. Before time 1, period 1, the platform commits to a privacy policy, which is an infinite sequence of privacy levels. Remember, privacy level in period T, gamma T, is the variance of the noise, this additive term. So higher privacy levels means the platform's commitment to acquire less information. Knowing the privacy policy, the consumer, for the moment, myopically chooses an activity level in each period. And since consumer is myopic, equilibrium means that the consumer takes the best response, and anticipating this, the platform sets a privacy policy to maximize its profit. So just to sum up, in each period, platform gets some signal. The quality of information is increasing in the activity level. While consumer enjoys the service, the consumer cares about privacy and dislikes information collection. And I'm interested in how much information will the platform acquires from the consumer. And this is non-trivial because consumer dislikes information collection, and consumer can choose to set 0 activity level to generate no information. However, this is a notation that I'm going to use. First result, for any given value of a privacy parameter, V, in any equilibrium, sigma square T goes to 0, and activity level A star T converges to A max as T goes to infinity. In words, this means that as T goes to infinity, the platform perfectly learns about consumer's type, so the consumer loses privacy in the long run, but activity level converges to what maximizes UA, ignoring the privacy cost term, so the consumer behaves as if there is no privacy cost in the long run. Now, so how does the firm manage to get full information in the long run? And point 2 gives some hint. Point 2 says, given any period tau, fix it. If the consumer puts high value on privacy, then the platform commits to offer a positive privacy levels in any period T weekly before time tau. So the platform may offer a positive privacy levels in early periods in equilibrium. But for any parameter, as T goes to infinity, this privacy level converges to 0. So this means that platform may choose a non-stationary privacy policy, in particular, typically declining privacy levels. And what I'm going to show you for the next few minutes is to give some intuition for why this long-run privacy loss happens. And the starting point, as you may imagine, is the consumer's trade-off. The consumer is myopic, but in each period, the consumer balances 2 things. The consumer enjoys benefit from the service, but the consumer incurs a privacy cost from data collection. And precisely, the consumer balances the marginal utility and marginal privacy cost, where the marginal cost is a derivative of the second term privacy cost with respect to AT, which is hidden in this expression. And a key lemma, key intuition, is that this marginal privacy cost term is smaller when the platform has already collected a lot of information. In other words, when the consumer already has less privacy, the consumer has even less incentive to protect privacy marginally. Intuition could be that if Google already knows everything about me, then I may not care about letting Google Map track my location today, even when I might have cared about privacy from ex ante perspective. So As time goes by, if the platform collects more and more information, this reduces consumer utility, but this increases consumers' marginal utility of keep using the platform. This divergence between level of utility and marginal utility of the consumer is the one feature of this model. And that means that once platform collects some information, it becomes easier and easier to collect more and more information. So the question from platform perspective is how to get this initial bit of information. Now, let me show some intuition about how equilibrium dynamics look like. In early periods, platform does not have much information. So if the consumer uses the platform a little bit, platform can incrementally learn a lot about this consumer. That means the consumer faces a high marginal privacy cost, and if the consumer places a high value on privacy, they may just choose 0 activity level. But then the platform can commit to offer high privacy level, reduce the marginal cost, and incentivize the consumer to choose a positive activity level. So in early stage, intuitively, platform offers privacy, and a consumer chooses positive but maybe small activity level, and a platform learns about consumers slowly and gradually. Later on, after long periods of interaction, platform learns a lot about the consumer, at which point the consumer has negligible incentive to protect their marginal privacy. And then to get the rest of the information quickly, the platform will lower the privacy level to speed up learning without discouraging the consumer's activity. So this consumer's change of the consumer's incentive to protect privacy over time drives the platform's optimal privacy policy. Now, so my interpretation of this result is that this tells us 2 conditions under which the consumer privacy can be difficult to sustain, and the business of collecting and monetizing data from consumers tends to be profitable. So one is, again, really about this assumption of the consumer's declining marginal incentive to protect privacy. So that means platform face increasing but concave cost of obtaining information. This may potentially explain the so-called privacy paradox, which is that while consumers express concern about privacy, many of them do seem to share their data with third parties. This may be consistent with a divergence between the consumer utility and marginal utility from giving up information. Another important assumption is the platform's ability to commit ex ante to add noise or underuse data. By doing something suboptimal ex post, the platform can enhance the quality of information from ex ante perspective. And I impose a strong long-run commitment assumption on the platform, but as long as the platform has 1 period ahead commitment power, we get exactly the same equilibrium. Now, so facing the monopoly platform, consumer privacy is unlikely to be sustained. What about when there are multiple competing platforms trying to get consumers? Let me just give you an intuition for why competition may not resolve this problem. Again, going back to our key intuition of decreasing marginal privacy cost. When there are multiple platforms in the market from which the consumer can pick one, this means that the consumer has a higher incentive to keep using the platform on which they have a lower privacy. So if there are multiple platforms, this gives advantage to the platform that has more data. For example, if I face Google, a new player, I might as well stick to the Google because marginally, I have nothing to lose against the Google. So I may stick to Google instead of starting a fresh interaction and give up new data to the new player. So I show that this makes the consumer switching to the new player or entry of even better platform less likely. This may be relevant, for example, in market for search engines because price is typically 0, like in my model, and privacy seems to be one measure of competition. So this may suggest competition of offering better privacy protection. There may be a reason to think that this may not be successful. Now, having said that, these results depend on somewhat strong assumption that once the consumer's information are collected, consumers are unable to erase information. But if there is a regulation like the right to be forgotten, like in Europe, and consumers are able to erase information collected in the past, then as I show in the paper, this promotes competition and benefits consumer in terms of privacy and welfare. Okay, now, so another caveat is that going back to the monopoly, I assume that consumer is myopic, which is strong. But myopia is not really important. The one result I show is that even if the consumer is forward-looking, any discount factor between 0 and 1, and the platform has only short-run commitment power, so 1 period ahead commitment power, still in any equilibrium, consumer loses privacy in the long run and chooses a high activity level. So what's driving this long-run privacy loss is not the consumer's lack of ability to foresee the future, but about the consumer's declining marginal incentive to protect privacy in the long run. Okay, so there are so many papers related, but I'm skipping this. Here is the recap. So that if there is one thing you could remember from this talk, this is the consumer's declining marginal incentive to protect privacy. This is an assumption, and the intuition is that when I have less privacy, I have even less privacy to protect my marginal piece of information or marginal privacy. I show that monopolists can leverage on this property to acquire a lot of information from consumers over time, even when consumers purely dislikes information collection and potentially forward-looking and could choose to be inactive to generate no information. Competition may not be effective in resolving this situation because the declining incentive means that consumers have higher willingness to pay to stay with a platform on which they have a lower privacy. However, if the consumers can costlessly erase the information collected in the past, this may promote competition and mitigate some of these bad outcomes for the consumers. This is all I have. Thank you very much for listening.